Hello bachas, welcome back to the channel The F in Physics, where the F in Physics stands for fun. Now this video is about refraction diagram. What is refraction? Refraction is when a wave travels from one medium to another medium, and if the density of both the mediums are different, then the speed of the wave changes, due to which the wave bends. So this bending of wave, irrespective of the type of wave, it could be water wave, sound wave or light wave. So this bending of wave when it travels from one medium to the other due to the change in velocity is called as refraction. Now in this video we will only focus on what happens if the speed of the wave decreases. Now the question is, sir, when does the speed of the wave decreases? It's different for different types of waves. Say for example, if it is a water wave, then the speed will decrease if it moves from deeper region to a shallower region. If it is a sound wave, then the speed is going to decrease when it moves from more dense to a less dense medium. And if it is light, the speed is going to decrease when it moves from less dense to more dense, because sound and light behave the other way around. Okay, so coming back to what will be given to you all. So this is what you need to know: when does the speed of the wave decreases depending upon the type of wave. Now coming to the question, they will give you a setup like this, a diagram like this, incomplete diagram, where they will give you an interface. I have taken the interface tilted. They will give you wave fronts and they will give you the direction of the wave, which is also known as wave normal. Now in the last class we discussed that wave normal is perpendicular to the wave front. There will be number of wave fronts and only one wave normal given, and you will have to continue the diagram to show refraction. First thing you need to do is, now begins your actual diagram. You can take the pen and pencil and you can note down the steps. First thing is, you need to extend the wave normal. Okay, but this is what most of the teachers do. I don't prefer this. What I will rather recommend you all is to draw a new wave normal. Now if you are wondering, sir, ye kaise banao? Always remember, wave normals are perpendicular to wave fronts. So at any wave front, I can draw a wave normal. Another recommendation, don't draw it at these points, because it will be very difficult for you to move forward. Select two wave fronts, draw a wave normal anywhere in between. Say for example, I go for these two wave fronts and I draw a new wave normal. The only thing you need to keep in mind is that the new wave normal should be perpendicular to the wave fronts. So if this is my wave normal, again you treat your wave normal as the incident ray, which means at this point of incidence you will have to draw a perpendicular to the interface at the point of incidence. So this is my perpendicular drawn. So incident ray drawn, a perpendicular drawn. This becomes my angle of incidence. You don't need to mark this, just remember. Now this wave which was moving forward will bend. The question is, where will it bend? So you need to remember, if the speed decreases, it will always bend towards the normal, which means instead of my wave going straight, my new wave will be bent towards the normal. So by how much will the wave bend? That is given by refractive index, which you don't really have to consider in this diagram. So by any angle you can make it bend towards the normal. Just make sure it is visible with naked eyes. So this is the new position of, or this is the new path, that the wave is going to take. So I am done with my wave normal. Remember, even for reflection diagram, we first constructed the wave normal, then we constructed the wave fronts. For all the wave diagrams, we are going to do the same. Now bachas, I need to draw my wave fronts. Okay, if you draw this, you will see that your wave front is not perpendicular to the wave normal. So you need to tilt your scale so that your rule is perpendicular to the wave normal, and you just keep sliding it until you meet the first wave front. So I slide it until I meet the first wave front, somewhere over here. This is my first wave front at the interface. My rule almost perpendicular to the wave normal. So this is my first wave front. You need to drag this down to draw the second wave front. I keep dragging it until I reach the third wave front. and then the fourth wavefront. This is what you need to do. Once you are done with your diagram, you will see that the new wavelength compared to the first wavelength has decreased. Why is this? Because your speed decreases. You know V is proportional to lambda. In this case, your speed is decreasing, which means your wavelength will decrease, which is very evident from the diagram, and your frequency remains the same. So if I just fill this up, my speed decreases, wavelength decreases, frequency remains the same or unchanged. Okay, so because of space constraints, I was not able to draw it, but with practice, after doing 2 or 3 diagrams, you will be able to slide the rule very easily. So I hope this part of refraction diagram was clear to you all. Thank you.